In the last few videos, we talked about the laws and the identities and the definitions of the trig functions. And so what I want to do in this video is I want to hop over to Geogebra and just give us a little bit of an intuitive sense of how these functions look and what their values are at kind of key values. So it's the kind of thing that can be helpful to just hear sine and have a picture of a graph in your mind. So let's go ahead and do that. So here is the graph of sine. Remember, we said in the last video that it's an odd function. And looking at this, you can see that if we rotate that 180 degrees about the origin, it would line up with itself. The red lines I have here are drawn at x equals pi over 2 and pi and 3 pi over 2 and 2 pi. Remember that when we do calculus, we always think of our trig functions in radians and not in degrees. Maybe if you are interested, and let me know, I can make a video about why radians are the quote unquote right way to think about how we measure, the domain of angle measurement. But you'll see in a video or two that it makes life very, very convenient. So the sine function starts out, the sine of 0 radians is 0, and then it comes up to the sine at pi over 2 is equal to 1, which is its top. You can think of this as 90 degrees if you want to, but if you can get your mind around pi over 2, that would be beneficial to you. And then it kind of drips back down. You notice that there's some symmetry happening here, and it drifts down, and sine of pi radians is equal to 0 again, and that's 180 degrees. And then once again, there's some symmetry going on between these two quadrants, and the sine at 3 pi over 2 is equal to -1, which is as low as it gets, and then it works its way up, and sine at 2 pi is again equal to 0. And this is a periodic function like all of the trig functions, which means that this shape just repeats itself over and over and over again to infinity. All right, so there's the sine function. Let's take a look at the cosine function. I'll look at the sine and cosine functions together so you can see that it's really just a phase shift, that they're almost the same function, just a little bit of, a switch of which values are which as it's going through its wave. So the cosine at 0 is equal to 1, and then it works its way down to the cosine of pi over 2 radians is 0. The cosine of pi radians is -1, which again is as low as it goes. The cosine of 3 pi over 2 radians is 0, and then it gets back up to its peak at 2 pi radians, where the cosine is equal to 1 again. So you can see that these functions, there's a similarity between that shape and that shape. So the sine, cosine, very, very similar functions. The tangent function, remember that we defined tangent as being sine over cosine. That was one of our identities. So everywhere the cosine is equal to 0, that's going to be the denominator in the tangent function. So the tangent is going to be undefined every time the cosine is equal to 0. So let's look at the cosine and tangent graph together. All right, so you can see that the tangent of 0 radians is 0, and then it goes up, and the tangent of pi over 2 is not defined because that's sine of, if you like, sine of 90 degrees over cosine of 90 degrees, which is 1 over 0. That's undefined. And then it picks up from -infinity, and the tangent 3 pi over 2 radians is equal to 0 again, and then it rises again. So you can see that the period here is actually pi, that whatever its value at 0 is, that's the same as its value at pi and 2 pi and 3 pi. So the period, the amount of time it takes for a graph to repeat itself, for the cosine wave here, it takes 2 pi to go through a whole rotation. But for tangent, it only takes 1 pi to do that shape. Same thing's going on with the cotangent graph. except that cotangent is cotangent is cosine over sine. So now every time the sine is 0, the cotangent is undefined. And every time the cosine is 0, the cotangent is equal to 0. All right, so that just looks like that. The secant graph, remember, secant is 1 over cosine. So once again, we've got this notion that everywhere that the cosine is 0, the secant is going to be undefined. But it flips back and forth between these positive and negatives. They look a little bit like parabolas, but they are not parabolas. That is what the secant graph looks like. So that is secant. And then once again, cosecant is a very similar looking graph to the secant, just shifted over a little bit. Okay. So I think having an intuitive sense of what these graphs look like, especially the sine and cosine graph, is going to kind of give you a notion that will help you with your intuition every once in a while when they talk about real world problems that involve trig. But the one thing that I want you to take away from this, from looking at these 6 graphs, is that the graphs are defined everywhere unless you've got a sine or a cosine equal to 0. And then in one or the other of those cases, you're going to have an undefined point of those graphs. But other than that, at any point at which the function is defined, it's continuous and it's going to be differentiable. So we're going to be able to talk about what the derivative is of these 6 functions, and it's going to be able to be something that we can compute and something that will define them for every point where the functions themselves are defined.